Hi, my topic was about GPUs in general and Nvidia in particular. Nvidia is arguably the leading company in the GPU market currently. It is widely used in accelerated computing, not only for gaming, but also for mining cryptocurrencies, simulating complex engineering graphs, or editing top-tier quality content. So, what's the next move of Nvidia, and how does it relate to the future of computer architecture? Well, NVIDIA has its hands on multiple fields. It is impossible to cover everything in just a small presentation, so we will only focus on AI and autonomous machines in particular, and the next generation of NVIDIA GPUs that is rumored to be extremely powerful. Autonomous machines employ AI to solve some of the world's toughest problems, right? The NVIDIA Jetson platform gives the tools to develop and deploy AI-powered robots, drones, IVA applications, and others. For example, what we call intelligent video analytics. It can give real-time actionable insights through streaming video analytics, and that could help a lot in enhancing security features in big buildings, for example, and also improving machine learning in general. On a computer architecture perspective, Jetson AGX Orin is used in this type of machines, and currently it's using a high speed input and output, 204 gigabytes per second of memory bandwidth, and 32 gigabytes of DRAM, which are capable of feeding multiple concurrent AI application pipelines. Just imagine what one can be done if more advancements are made in this field of AI and deep learning. A faster and more compact chip would allow deep learning to be much more efficient on embedded systems, and thus creating machines that can solve complex issues on a very short time and using much less energy. Exciting stuff, right? Now, regarding the GPUs that Nvidia will release at some point, that GPU considered is called the GeForce RTX 40 series of graphics card that is based on the ADA Lovelace GPU architecture. I hope I spelled that already. It is rumored to have almost twice the power of the current RTX 3080 chips. Just to give you some context, the RTX 3080 series runs at 34 teraflops. The next one that is rumored to be released runs at 68. Will be able to run at 68 teraflops. Going back to the ADA Lovelace architecture, it is using a 5 nanometer architecture instead of 8, and it runs at 71% faster than compared to the current Ampere architecture that is being used now in the 3080. In terms of performance, this new release will offer a rough double jump of the current one. Yeah, of course, Moore's law hits you in the head. But it is also rumored that it will have a boosted 144 streaming multiprocessors and a maximum of 18,432 CUDA cores, again, almost double the number of the RTX 380. Moving on to the second question for this presentation. One of the most intriguing questions that I have received in the forum was the one of Zakaria, when he asked about differences between NVIDIA models, notably GeForce, Quadro, and Tesla. If you ask a gamer who is keen about architecture, he or she most probably will tell you that they're using NVIDIA GeForce models in their gaming machine. But why, for example, not use Tesla? Well, the thing is that NVIDIA manufactures different models for different purposes, right? Every one of them is unique and is good at doing its job, in its field. Let's look at this in more detail. GeForce is specifically made for gaming, which makes it the less expensive one. It is supporting the ECC error correction code, ultimate ray tracing for advanced graphics display, and even AI technologies. And all of this is just to make your gaming experience exclusive and great. Tesla, on the other hand, was initially the name of NVIDIA's line of products for GPUs, or what we call general purpose GPUs, right? And you can mostly find it in supercomputers. It has much faster 64-bit floating point speeds. It may reach 10 times faster than its equivalent in Quadro or GeForce, and they are pretty small and expensive, which, makes them a great fit for their purposes. However, in comparison to GeForce, for example, it cannot render graphics. You see, Tesla is very fast and is very good in what it does, but it cannot even render graphics, which is the area of the GeForce, for example. Quadro model is intended to be used in workstations, right? Running professional computer-aided design, computer-generated imagery, digital content creating, scientific calculations, and even deep learning. They have pro drivers, and their best versions contain the largest possible VRAMs, as well as memory pointers. Large amounts of VRAMs are mostly used in rendering 3D graphics of images that are very, very complex. So you can find Quadro also used in a lot of video editing and content creating. Basically, those three NVIDIA models are all powerful in what they do. Just like CPUs, many of them are made as general purpose, but some of them are specifically used to do specific tasks, and they can be good only at those tasks. The story doesn't nearly end with a difference in the models. Every model by itself has multiple variations, and sometimes the differences are super minor, very minor. They can change in the number of CUDA cores, base and boost clocks, and memory specs, and so on. With that being said, sometimes NVIDIA releases a GPU that smokes the one that is preceding it in a year or less, just like the one that we just talked about, the RTX 40, that may be released in 2022. Finally, I think that Hanan's presentation about tensor processing units, or GPUs in short, is one of the most significant topics presented in this class, especially that it has close relation to deep learning and AI in general, which are very, very interesting fields nowadays. A TPU is an AI Accelerator Application Specific Integrated Circuit, or ASIC for short, developed by Google specifically for machine learning. In my presentation about GPUs, I noticed that GPUs are made to cover or to satisfy specific tasks that CPUs could not achieve alone. Those tasks require millions of repeated mathematical operations, and the architecture of the GPUs makes them perfect, the best fit for achieving them. GPUs seem to solve most of the computing heavy problems until machine learning kicked in. Because of the fast-growing computational demands, especially of neural networks in machine learning, GPUs were simply not the solution. So GPUs were invented. And that's what actually makes GPUs a very significant topic in computer architecture, because of this problem that they can solve of dealing with multiple with very, very heavy computational problems. If we dive more into the architecture of GPUs, we will find that that a GPU is basically just a matrix machine. So they use a lot of matrix operations, which is different from scalar or vector that are used in CPUs and GPUs. From Hanan's presentation, it is clear how TPUs outperform GPUs in solving matrix operations, which are directly related to machine learning problems. It is also important to note that GPU devices are used in cloud computing, which is called Cloud GPU. It is designed to run cutting-edge machine learning models with AI services on Google Cloud. And it has a custom high-speed network, offers over 100 petaflop of performance in a single pod. I honestly have learned a lot from this class, especially by researching about a lot of not just computer architecture topics, but computer science in general, and also by learning from my classmates as well and their presentations. So, thank you for this class, and goodbye.